All right, class. We want to review quadratic factoring. Okay, before we review factoring, let's first review multiplications. All right, we have a two-term multiply to each other. So how does that go? So we can use distributed property. So I can say x plus 3 times x and x times x, x plus 3 times -4. All right, so in the multiplication, so it's x plus 3 times the first one, x, and then times the -4. All right, so that's what it is. And so this is equals to, again, distributed property here. So x squared plus 3x plus, let's do this, right? So you have x times -4. Let's change it to positive. How about that? Positive, okay. So so that's plus 4x plus 12. And so this is equal to x squared plus 7x plus 12. As you can see, the constant term, the one is a constant, 3 times 4, get 12 right there. So this comes from 3 times 4. So the 7x come from the inside term, 3x are called the inside term, meaning 3x. So this 7x come from 3x plus 4x, and the 3x come from inside term, and the 4x come from the outside term, these two. All right, so with that in mind, we can call, so we understand that the 7x actually come from the addition, the sum of the two constant term, 3 plus 4. We say 3x, 3 times x, plus 4 times x. So we can say x plus 3 times x plus 4 is the factor form of the quadratic expressions, x squared plus 7x plus 12. All right, so we want to go backwards. We use this already known result to go backwards. So if we were to factor x squared plus 7x plus 12. How do we factor that? Well, let's check. Pretend we didn't know this is what it came from. Pretend we didn't know x squared plus 7x as a result of x plus 3, x plus 4. We say, okay, we understand we factor 12. So 12 can be 2 times 6. So we say, hey, let's try. X plus 2, x plus 6. Well, what we need to do is check the middle term. So what we have here is 2x and 6x. The sum of that is ax, which is not equal to what? 7x. So we know this is not correct. Then how many other factors you can have 12? 12 can be 2 times 6. Also 12 can be 3 times 4. Let's try 3 times 4. Of course, you can also try 1 times 12. That's not going to work. So let's try that again. So x plus 3 and x plus 4. Remember, the number 12 came from 3 times 4. So that's how we guess. So here, the middle term is 3x. The outside term is 4x. Now the sum is 7x. We know, yes, that's what it is. So that's how we factor. So we can say x plus 3 times x plus 4 is the factor form of x squared plus 7x plus 12. All right, so can we just do another questions? So follow that. All right, let's try factor the following: x squared minus 6x minus 27. Okay, the factors of negative 27. They can be, let's see, negative 1 times 27. You can be negative 3 times 9. You can be 1 times negative 27. You can be 3 times what? Negative 9. Let's try that first, all right? So the x squared came from x times x. That's how we write down first, right? Then we try this factor. Let's try -1 and plus 27. Then we check middle term. So I said -1x plus 27x, obviously. That's 26x and not equal to -6x. So that's the incorrect one. Well, let's try next one. -3 and 9. So x and x. So -3 plus 9. Let's check the middle term again. So -3x, 9x, that's a 6x. Okay, so obviously this is not 6x, -6x. But if you notice that if the quantity is the same, meaning 6 versus 6, or -6 for that matter, then you are in the ballpark. All you have to do is reverse the sign. The signs of -3 and 9. So there's no need to check 1, -7 anymore. Simply straight from -3, 9 to 3, -9. So let's see that. So x and x, let's see that. That's +3 minus 9. Now you have 3x minus 9x. The result is -6x. And that's correct. So we can say x plus 3, x minus 9 is the factor form of x squared minus 6x minus 27. All right. But what if a number, so the leading coefficient is not 1. We follow one more example, right? Factor the next one. Factor, let's say 2x squared plus ax minus 10. All right, obviously the only way to factor 2x will be, 2x squared will be 2x times x. All right, let's try something first, right? So -10, maybe try -5 plus 2. So -5 times 2 is -10. So let's try the middle term. So that's minus 5x and plus 4x. That obviously doesn't work because, well, that's -x, right? So not even close. So in this case, you might want to change 5 and 2. Let's try that again. That's a 2x, let's see, plus 2 and x minus 5. Okay, let's check the middle term again. So you have 2x minus 10x, so the result is minus ax. Okay, here, they is not equal to ax. However, they had the same quantity. So remember what we just said a while ago? Reverse the sign. So try 2x minus 2, 5 minus 5 plus x. Now you have -2x plus 10x ax, and that's exactly what this is. So the 8x right there. So we can say 2x minus 2, x plus 5 is the factor form of x squared plus ax minus 10. Now the reason that is, again, let's multiply this out, right? If you multiply this product out, it should be equal to this right-hand side. Let's try that. So 2x minus 2 times x, this is equal to, plus 2x minus 2 times 5. So that gives you, x minus 5, I'm sorry. Two x minus 2 times 5. So that gives you 2x squared minus 2x, and you have plus 10x minus 10. That's equal to 2x squared plus ax minus 10. So we verified that. That's indeed the factor form. All right, so that's the end of the lecture here. And we have some exercises on a web assign. I will assign it, and it will be due Wednesday after the fall break. Okay, and I will share this particular notes on the content area. You can see the content library. I will have let's just see under the solution to the test. I have a section called, I just call review. All right. Review of factoring. All right, I will share here. Then you can, you'll be here. You can see under the content library right here on the OneNote. You can see under the solution to test. You can see that. All right. Have a good break.